If you are a mobile phone technician and you are interested in learning further, you want to understand troubleshooting more better, then you should not skip this video. Watch the video to the end. There is one thing that I want us to talk about in this video, which is the type of short that I call a triggering short. So this type of short is that type of short where you have to trigger the power IC before you notice the short, even with your DC power supply. So I will show you an example and I'm going to explain. So you are looking at this short. When you connect the phone to your DC power supply, the DC power supply doesn't show that there is any short in the mobile phone, right? But as soon as you click on the power button, it will be like a normal powering on trigger that will show in the DC power supply. But if you check the triggering current, you will see that it's very high, and not all phones can even reach that type of current consumption even when they are in the boot screen. You understand, when they are in the desktop screen. So this type of short is also known as overcurrent trigger, because when you press the power key for the phone to start booting up normally, going through current stages, normally the phone will run up over 1 ampere, which is totally wrong. So the point of this video is not about this short, but how you can understand the components that are causing this type of short. First, I want you to understand that when you are troubleshooting, because you see a component hitting up in the mobile PCB, maybe you have sprayed your rosin flux in the mobile PCB, then you connect your DC power supply, inject voltage, because you have seen a component hitting up on that mobile PCB, that doesn't always mean that that component is the one that is bad. I've talked about this just a couple of times. You see, this triggering short that I'm talking about is mostly caused by different components, but they will cause components like the power IC, the charging IC, to heat up. You understand, especially the power IC. If you take a look at this phone that I'm working on right here, you will notice that when you press the power key, you will have that high current trigger, which is actually a short. When you press the power key, you will see that current consumption, which is because when you press the power key, the power IC start distributing the voltage to other parts of the mobile PCB. There is one particular part that is causing a short to that voltage that is being distributed to that section, to that particular section. And as soon as you release the power button, you will see that there is no hold in the current trigger, and that is because when you press the power IC start booting up, it's going to be blocked by that component that is shorting, and that's going to happen only when you keep pressing the power button. If you keep pressing the power button, you will also notice that maybe the charging IC or the power IC is going to heat up, and heating up doesn't mean that this IC is bad. And in most cases, if you are unable to test, then find this particular component that is causing the power IC to short, at times you will have to remove the power IC, then check the other components that were also shorting. In most cases, for you to be able to solve this type of short in a mobile PCB without causing more damage, or without saying that you cannot solve the problem because you have seen that the power IC is heating up, for you to confirm if the IC that is heating up is actually the problem, actually the IC that is causing the short in the PCB, you will have to go through the PCB step by step. You have to check sections, especially the processing section, like the CPU, around the eMMC. You will have to check capacitors around that section, and also around the Wi-Fi section and around the network section. These sections can cause that type of triggering short that will cause other ICs like the power IC to heat up. So when you check these sections, you are checking for the capacitors that are in that section, you are checking for the diodes that are in that section. Mostly they will be capacitors. You will also notice a few capacitors in the PCB that are also shorting, but if you remove those capacitors, it will keep shorting. So if you see a lot of capacitors that are shorting, you keep removing and the short is still there. The best way for you to know if the power IC is the one shorting in the mobile PCB is for you to remove that power IC, then set your multimeter to the continuity test mode again, then check the capacitors that were shorting when the power IC is still there. If there is no short, you remove. If there is no short, that means that the power IC is bad and you have to replace the power IC. But if you remove it and you still see shorting in those components, that means that you can then inject your voltage in those components, then you will be able to see the particular component that is causing the short without the power IC interrupting, like acting as if it's the one that is shorting. So this video is for you to be able to take time troubleshooting problem in a mobile PCB, and don't just consider that okay, this IC is heating up, it's shorting, this one is heating up, it's shorting. If you see me posting a video of an IC heating up and I say that IC is bad, it's because I've already examine the PCB, troubleshoot the PCB step by step, and I've already confirmed that the IC is shorting. Well, I'm saying is Mike right here. If this is the first time coming across my videos, make sure you follow and like, and also check my course. If you want to learn everything step by step, check my course in the link in my bio or in the video description, if in case you are watching this on YouTube, and send me a message on WhatsApp if you want to buy my courses directly from me. So thank you and see you soon.